Feko is Altair's powerful 3D electromagnetic design and analysis tool, allowing users to model and simulate an extensive variety of devices. Additionally, related tools in the Feko package allow designers and engineers to analyze co-site interference as well as medium and large-scale wave propagation. Today, we will take a look at setting up a simulation in Feko, and we will point out a few tips and tricks to expedite the design process. The units of the model can be set to one of many metric or imperial options. In addition to the default perfect electric conductor and included media library, various substances can be defined and customized, including metals and dielectrics. The variable editor allows users to define variables to easily identify and edit geometries and device parameters. Under the Construct tab, users have access to a suite of 2D and 3D shapes with various CAD design aids, such as geometry unions, intersections, and subtractions. For engineers wanting to start with baseline designs or standard models, Feko comes with a library of standard components, such as various antennas and waveguides, as well as some larger geometries, such as sea ships and flying vehicles. Users can also import custom designs, including geometries, meshes, and PCBs. In addition to custom macros and scripting, the software includes pre-built macros to aid in geometry manipulation, such as path sweeps, allowing users to quickly make complex geometries. Parameter sweeps automatically create and simulate new models over a given range of parameters, allowing users to optimize individual values within a specified range. Users have the option to tell the tool exactly what information they want to extract from their model under the Request tab. Some of the more common requests include near fields for 2D areas, far fields for 3D volumes, and S parameters for multi-port devices. Configuration settings allow users to run simulations configured with different frequencies, sources, powers, and loads. Feko can automatically mesh your geometries, but users can also customize the meshing settings, such as mesh sizes or approximations for curved components. The option to view the count and statistics for each mesh shape is also available. Once users are ready to run the solver, they can verify the model status and identify any errors before running the simulation. The ability to define symmetry allows the solver to mirror certain calculations, reducing runtime. Based on the model, users may wish to alter the solver settings, which allow customization in data precision, output files, and even the solver being used, such as MOM, MLFMM, or FDTD. After running the simulation, post-Feko can quickly be launched to immediately view the most recent results. Altair Feko has a wide variety of applications in the field of electrical engineering, allowing users to quickly design, analyze, and optimize an impressive array of electromagnetic devices. With some of these tips and tricks in mind, the power of this tool grows exponentially, allowing you to increase your productivity. For more information on Feko or other Altair resources, reach out to us at trueinsight.io.